Making predictions is where we take what we've learned about probability and what you've learned in the previous unit about proportions, and you can use that to predict things that may happen in the future. So first, a prediction. This is something that you can reasonably expect to happen in the future. Think about a meteorologist. They make lots of predictions, and our lives really depend on, can they reasonably expect something to happen in the future. They take the situations in the weather, what's going on in the atmosphere, they take what those circumstances have led to in the past, and they apply that to make a prediction. They look at percentages of when such and such was happening with this type of cloud or with this type of front coming in, and they use that to predict what can happen. And we are very dependent on that because our lives in many ways depend on the weather. So when you join the forces of probability and a proportion, you can make a prediction. So put these three P's together. Probability plus a proportion equals a prediction. Probability and proportion gives you prediction. If you roll a number cube 15 times, about how many times do you expect to roll a number less than 6? So I can take the probability. The probability of rolling something less than 6 is 5 out of 6, because that means I could roll 1, 2, 3, 4, or 5, and all 5 of those outcomes fit the criteria of a number less than 6. Then I take that prediction and apply it to a proportion. 5 over 6 is equal to x out of 15. I decided to put x on top because what I'm wanting to know is about how many times can I expect to roll less than 6. That's what 5 is related to. 5 was how many times I can roll less than 6. 6 is the total possible number of outcomes. So if I have 15 trials, 15 times I'm going to roll, how many times can I expect to be less than 6? If you'll remember the proportions to solve those, you cross multiply. 5 times 15 is 75. 6 times x is 6x. And then I solve that proportion by dividing both sides by 6, and I get 12.5. I wouldn't say that I'm going to roll this 12 and a half times. So I can translate that to the prediction of I expect to roll a number less than 6 12 or 13 times. That is an okay answer to have two different things, 12 or 13, because they're wanting to know about how many. This is a prediction. Here's another way that you can use this. Caitlin's free throw percentage is 65%. If she goes to the line 6 times, how many shots is she expected to make? Coaches use this all the time. If they are at the end of the game and they're needing to foul to get the possession back, they will foul somebody, and they want to foul the person with the lower free throw percentage because they don't want the person to hit those free throws. So I can take my probability, 65%, connect it to a proportion, and then that will give me my prediction of how many shots she's expected to make. 65 over 100, that's the free throw percentage. Remember, 65% is comparing 65 to 100. That equals x over 6. Then I will cross multiply. 6 times 65 is 390. Equals, and then I'm going to multiply 100 times x and get 100x. Now to figure out what x is, I'm going to undo multiplying by 100 by dividing by 100 on both sides. And I'm going to get 3.9 equals x. So if I were to write this as a prediction, I wouldn't write 3.9 free throws because she can't make 0.9 of a free throw. I would say about 4 free throws. Here's some practice problems for you. Go ahead and attempt those and then compare with what I come up with. Okay, part A says the wettest city in the U.S. is Mobile, Alabama. The city's chance of rain is 16%. So out of a 30-day period, about how many days would you expect it to rain in Mobile? So I converted 16% to the ratio of 16 out of 100. And how many out of 30? So I've set my proportion up, then I'm going to cross multiply. 16 times 30 is 480. 100 times x is 100x. Then I undo multiplying by 100 by dividing by 100 on both sides. And in case you haven't noticed, when you're dividing by powers of 10, however many zeros there are is how many places you move the decimal over. And you get 4.8. So about 5 days you would expect it to rain in a month in Mobile. Part B. If 12 out of 15 people recycle, how many people out of 1,000,000 would you expect? So I'm taking the probability, 12 out of 15, and I'm putting it into a proportion. 12 over 15 equals x over 1,000,000. I solve that proportion to get my prediction. So 12 times 1,000,000 is 12,000,000. 15 times x is 15x. Undo multiplying by 15 by dividing by 15 on both sides. You get x equals 800,000. Then I'm going to take that value and put it back into the context of the question. So you could expect about 800,000 people to recycle.